Alright, chemists, so part 2 of moles. Let's have a look at where we would use this in a question, and where it would, I mean, this is where it would be useful in a lab, to be honest. So here's our chemical reaction we saw from earlier. We have, this is the combustion of ethanol. So here's the ethanol, and so for every mole of ethanol you've got 3 moles of oxygen, 2 moles of carbon dioxide and 3 moles of water. Now do yourself a massive favour and write that down right now so you can keep coming back to it. You're about to learn why in chemistry, like math, we want you to show you working, keep you working there, okay? Alright, so our problem, we have 17 grams of ethanol. When we burn that, we want it to burn efficiently, so we need to know how much oxygen we need to reach completion of this experiment, so it goes to completion, and what we're going to get out of it, what's it going to yield. Alright, so first thing we want to do mole ratios, okay, so we want to talk about this, how much of this we need to this, okay. So we need to know how much we have. Alright, so the moles of ethanol is, again, mass over molecular mass. We need to work out, we know what the mass, that's given to us in the question, 17 grams. And from there, it's the only number given to us. And we have to work out the rest. Alright, so the molar mass is, again, that's your carbons added together, that's all your hydrogens, that's your oxygens put together. It is 46.08 grams. Now, again, that's not the mass we have, that's the molar mass. So remember these numbers, 46.08 and 17 grams. And we bring this one over. Alright, so the moles, how much do we have? What sort of mole do we have? We have 17 divided by 46.08, and it gives us 0.37 moles. Okay, so that's how much ethanol we start off with. So essentially that's the unit of how many molecules of ethanol we start with. This means we need to know how much oxygen we need. So we need to work out how many moles we have. 3. This is the coefficient from out the front, so that's our ratio, 1 to 3. So we have 0.37 times 3, it's 1 to 3, so it's actually, we need 1.11 moles of oxygen. Okay, so, you know, let's be realistic. We need to know how much that is we're going to put in there. We're not going to sit and measure out moles, we have to measure out mass in grams. Now here's our formula, we've had to rearrange, okay? So we got moles equals mass divided by molar mass, alright? We know the mass, we want to know the mass, so we have to get that on its own. So to do that, because that's divided by, we times it by molar mass, and that gives us mass equals moles times molar mass. But that's not too hard, I hope we're not pushing you too far there. So work out how much oxygen we need. The molar mass of oxygen as a gas is 32, 16 times 2, times 1.1. We need 35.52 grams. Okay, so therefore the amount of oxygen needed for it to go to completion is 35.52 grams. So that's our first step. Now we wish to know what that experiment will yield, so what we're going to get out of it. Now, so first we work out the moles of carbon dioxide, so it's 0.37 again, times 2, which is going to give us 0.74 moles. Alright, so same formula, molecular mass for carbon dioxide is 48.01 grams. The mass that we'll have at the end is the mole times the molecular mass, it's 0.74 times 48.01, and this gives us 35.53 grams. So we will get out of it 35.53 grams of carbon dioxide. Water. Okay, so again, same as with oxygen. We've got 3 times 0.37, so we're going to have 1.11 mole. Our molar mass for that is 18.02. It's the same as the first video. Chemistry didn't change between now and then. The amount of the mass, what are we going to get? So we're going to mole times molecular mass, or molar mass, and it's 1.11 times 18.02, and it's 16.99 grams. So we will yield 16.99, which is grams, which is also 16.99 milliliters of water. Now, this is the cool part. Well, it's not, but I like this little bit at the end. Law of conservation of mass. You can't beat it. The mass of reactants is the same as the mass of our products. 52.52, 52.52. Now occasionally you'll have rounding errors in a lot of maths like this, which is why you need to show you're working. And again, rounding errors will happen when you're dealing with significant figures, etc. Alright, top work. Go over that a couple times if you need to. Pick a reaction out of your textbook, anyone. Give yourself a random number of grams, a random amount of grams of one of the reactants. Work it out. Alright, see you in class.